we're going to look at rational expressions. So that we need to be able to find the domain. In this first one, there's a couple things going on because we have the square root of x. Well, you can only take square root or even roots of positive numbers. Okay, so that means that our radicand, whatever we're taking the square root of, the radicand needs to be set greater than or equal to 0. Because we could take the square root of 0, that's fine. But we can't take a square root of something negative. Okay, so that's the numerator. And then the other issue, okay, so that's the one big idea, is set radicand equal to 0. And another one is that the denominator cannot equal 0. Okay, so if we had x squared minus 4 equaling 0, that would be undefined. So x squared when it equals to 4, so when x equals positive or negative 2, this is undefined. Okay, so if I was going to put these two pieces of information together in a graph, if I was looking at the domain, I would happily just be going along thinking I was fine, everything bigger than 0, except if I got to 2, I would have to skip over that and leave this little undefined place. So in set notation, it would say it's all the x's you want to give me, such that x is greater than or equal to 0, and x cannot equal 2. That negative 2 wasn't an issue anyway, because that's not part of it, that it can't be negative, okay, for the first condition. All right, and then we could write that in interval notation from 0 to 2, skip over 2, and head off towards infinity. So let's see, we found this is the domain. All of this is different ways of finding the domain. We wrote it in set builder, in interval, and we did the graph. Okay, so now if we're going to go and simplify this expression, what I can do is factor. So in the numerator, both of those are divisible by 3. So I'll go ahead and factor out a 3. And then in the denominator, everything's divisible by 9. So it would be x squared plus 2x minus 3. Okay, and then I can simplify my numbers here a little bit. So my numerator would factor as x plus 3, x minus 3. My numbers simplified down, so I just have a 3 in the denominator, and then I can factor x squared plus 2x minus 3, that factors as 2x. Oops. That factors as x times x, and then if we made this plus 3 minus 1, and then our x plus 3's can cancel, so I'm left with x minus 3 all over 3 times x minus 1. However, x cannot equal anything where it would give us something undefined in the denominator. So right here, right? Oh, that would create, if x is a negative 3, we would get ourselves a 0. Now you can write all of them that you want, like we could say, well, x can't be 0 or positive 1 from here either, but since it's obvious in the final problem, you don't have to write that one. It's just the ones from which you have canceled and you can't tell that you have a problem when x equals negative 3. That is no longer obvious in the answer. Okay, moving on, we're going to do a little division. So let's see, if I have a fraction divided by a fraction, I can copy the first one. I'll go ahead and factor that. Let's see. About x minus 3 and x plus 2. And x squared minus 1, that factors to x plus 1. x minus 1. Okay, I'm going to change to multiply times the reciprocal of that second fraction. Okay, so we changed from divide to the reciprocal, multiply times the reciprocal of the second fraction. Okay, then we'll go ahead and factor that. I'm going to run out of room here, but that's okay. So we have x minus 3, x plus 2. I'll just go ahead and copy that down. And then the second one factors to x plus 1 times x plus 1 all over x plus 2, x minus 2. And then we look for anything that might simplify. We have an x plus 1. I have an x plus 2. Okay, since those canceled out, I want to make sure that I show x cannot equal negative 1 and also negative 2. And then this finally simplifies down to x minus 3 times x plus 1 in the numerator, and then we had x minus 1, x minus 2 in the denominator. All right, so moving on to adding and subtracting, we need to get a common denominator. And to do that, it's helpful to factor first. Okay, so factoring down in that first denominator, we'd get x minus 2, x minus 1. Second fraction, we'd have x minus 1, x plus 1. All right, so both of them have an x minus 1, but this one has an x plus 1, so we need a common denominator. So we're going to give that first fraction an x plus 1, and let's see, we have an x now plus 1. Yep, this one doesn't have an x minus 2. So, okay, so giving ourselves that common denominator, now we are going to have x, distribute that in, squared plus x, and then this distribute the whole thing, that negative 2, multiply it times x and times the 2. So minus 2x plus 4 all over that whole denominator. So we get x squared minus x plus 4 all over the denominator. And we just want to pause for a second and just double check and see if maybe the numerator could factor, because sometimes this can simplify, but it doesn't. And so we're done, and we just have the domain restrictions. Let's see, x cannot equal negative 1, 2, or 1. All right, let's look at example 5 where we have a complex fraction. So what most people want to do is get a common denominator up in that numerator, and so I would multiply by x plus 1 over x plus 1 in that second fraction, and then multiply by x over x in the top fraction, and then that would give me x over x times x plus 1, and then I would be subtracting that. Let's see, distribute that negative, subtract both the x, also the 1. And then my x's add up to 0. So this would give me negative 1 over x times x plus 1. And then dividing here, dividing by 1 over x, that would be the same thing as multiplying by x over 1. So we'd get negative 1 over x times x plus 1, and our x's can cancel, and so that gives us negative 1 over x plus 1. There. All right, so there's one way of dealing with complex fractions. You just kind of take it step by step, and there was subtraction in the numerator, and so we can simplify that by getting a common denominator and combining those numerators up in that original numerator. Now I want to show you another way that can be just a tiny bit shorter, so let me go ahead and get started. Okay, if we look at the denominators and see there's an x plus 1 and an x, and we don't have to repeat
and multiply multiple times. But what we're going to do is we're going to take both the numerator, x times x plus 1, and the denominator. So we're basically just multiplying by this well-chosen 1 right there, okay? And what that is the LCD of all of those fractions, okay? And then that's actually going to be all over 1. Okay, we're going to distribute that up here. So we would have x times x plus 1 all over x plus 1. Those are going to cancel. Then we're going to have 1 over x times x plus 1. So up here we would have 1 times x plus 1. And those x's divide out to just 1. And then down in the denominator, we've got x times x plus 1 in the numerator and an x in the denominator. And our x's cancel. And then that would give me here, that simplifies to just x. And then this simplified to minus x plus 1, distributing that negative, we would have minus x and then also minus 1. And then in the denominator, we have x plus 1. These x's just add up to 0, and so then that gives us negative 1 over x plus 1. So as we move forward, I'm going to use this strategy of simplifying complex fractions by multiplying by the least common denominator, because a lot of times it'll end up just being a tiny bit shorter. Okay, so let's work on this next one. I'm seeing that the LCD needs to have an x plus 2. X squared minus 4, that is equal to x plus 2 times x minus 4. So the least common multiple here would just be x plus 2, x minus 4. Okay, so I'm going to deal with this complex fraction by multiplying by the least common denominator, which is x squared minus 4. X squared minus 4 all over 1. Okay, so now I have to distribute that in the numerator. So that would be x times x squared minus 4 minus x squared minus 4 all over x squared minus 4. And then here, just multiplying straight across, I have x squared minus 4. I'm looking right here. I'm going to go ahead and just write that out as x plus 2, x minus 2. Just go ahead and factor that. And then that would all be over my x plus 2 from right here. Okay, so my x plus 2's can cancel. My x minus 4's just cancel. Anything divided by itself is just 1. And so that gives me, go ahead and distribute, x times x squared would be x cubed minus 4x minus 1 all over x minus 2.